Hello class, and welcome to Chapter 7, which is going to be all about polynomials and factoring. As I mentioned at the beginning of Chapter 6, we skipped over Section 6.1 because it was going to be part of Chapter 7. So we're going to start with that today. We're going to have a second video on that tomorrow, and all of this is going to be about exponent properties and how we can use exponents. By the end of today's lesson, you will be able to use exponent properties to simplify expressions. First, we're going to do a quick review. We've got right here x to the n. Quick review of what these terms are. This bottom part is called the base. This n value up here is the exponent. And the whole expression together, the base and the exponent, make up what we call a power. So, if, for example, we had 3 raised to the 4th, what that means is you're taking the base, which is 3, and multiplying it the number of times of the exponent, which is going to be 4. So base multiplied by the number of the exponent, which in this case was 4, giving us 81. Once we start using these rules, our goal is going to be to simplify any variable expressions that we have. If that happens, every variable has to appear exactly once. So if there were 2 a's by the start of in the start of the problem, by the end, letter A can only be listed once. There's going to be no powers of powers. I'll get to what that means momentarily. Anything that's a fraction has to be simplified, and then there's going to be no negative exponents. So what that means is this n value up here can't be negative. Again, I'll go over how to get rid of that momentarily. Our first property that we're going to look at is called the product of powers. So this says when multiplying 2 powers with the same base. So notice we've got group 1, group 2, there's 2 of them, and they've got the same base. Both of them have b. We're going to go ahead and add their exponents. Why does this happen? So the answer is going to be b to the 8th. But why? This first one means b times b times b. And then you're multiplying, and then the second part is saying you're multiplying by b times b times b times b times b, which if we count is 1, 2, 3, 4, 5, 6, 7, 8. So b to the 8th power. This works if you've got 2, 3, 4, 5, however many powers. If they're being multiplied, you're always going to add their exponents up to get the total exponent for that property. So for example, if we have these 2 powers being multiplied, it's okay that there's numbers in front. It's okay that they're more than one variable. They're still referred to as a power. If this happens, you need to look at each part individually. So the numbers, we've got -4 times -6, which is going to give us 24. Then we're going to look at the next part, which is r and r to the 5th. Remember, if it's just by itself, it has an exponent of 1. So that's 1 plus 5, which gives us r to the 6th power. Then I'm going to look at the x's, which I've got x to the 2nd and x to the 2nd, giving me x to the 4th. And then the last part, we've got d to the 3rd, and d, again, with just an exponent of 1, giving me d to the 4th. So our final answer is 24, r to the 6th, x to the 4th, d to the 4th. When you're typing this into Edpuzzle, you would write it as 24r caret, which you get by doing shift 6, and then 6, x caret 4, d caret 4. So that caret is going to show you that it's an exponent, since you can't actually use a superscript to raise that actual exponent when you type it into Edpuzzle. Go ahead and try this one on your own. Multiply the numbers, add the exponents, we get -35, a to the 10th, b to the 14th. Our next rule is called the power of a power. So this is one of the things we're not allowed to have in a simplified expression. What this says is if you have a power raised to another power, then you're going to multiply the exponents. So if I have b to the 3rd to the 5th, I'm going to end up with b to the 15th. Why does that happen? When we have b to the 3rd to the 5th power, that means there are 5 b to the 3rds being multiplied. Each of those b to the thirds is made up of 3 b's. So 1, 2, 3 times 1, 2, 3 times 1, 2, 3 times 1, 2, and 3, and 1, 2, and 3, giving us a total of 15 b's being multiplied. So that's why when you have a power raised to a power, you're going to multiply. Again, if you have a power being multiplied with a power, it's adding. If a power is raised to a power, it's multiplying. So, for example, on this one, we've got 2 to the second, to the second, to the fourth. So we've got multiple powers being raised. You're going to want to deal with the inside one first. So 2 to the second raised to the second is going to give me 2 to the fourth. And that's still being raised to the fourth power. So then I've got to multiply again. And that gives me 2 to the 16th power. Again, when you typed that into Edpuzzle, that would be 2 caret 16. Go ahead and try this one on your own. Raising 3 to the 5th, we get 15, and then to the second, we end up with 3 to the 30th power. Our next rule is going to be the power of a product, and this is to find the power where there are multiple bases. So there's multiple pieces inside this parenthesis. Raise each base to the power. You can think of this as the distributive property of exponents. So what this is going to say is that we have -2, and the exponent on that was 1, so I've got -2, but now I'm raising it to the 5th power, so I've got -2 to the 5th. The x also had a power of 1, but I'm raising that to the 5th power, so now I've got x to the 5th, and then I've got y to the 3rd, raising that to the 5th power is going to give me y to the 15th. Again, why does this happen? So this is saying that the power that I have, -2x to the 3rd, I have that 5 separate times over. That's what raising it to the 5th power means. If I have each of these things 5 times, I need to account for all 5 of them in my final answer. So -2 to the 5th power. X, 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 and x gives me x to the 5th. 3 y's, another 3 y's, another 3 y's, another 3 y's, and another 3 y's gives me y to the 15th. So again, if you have multiple things being raised to the power, each individual piece needs to be raised to that power, just like a distributive property. So if I've got 3xy squared z to the 3rd, all raised to the 5th power, I'm going to go ahead and I'm going to start distributing. Remember, if you don't have an exponent, you can add that exponent of 1 in. So I've got 3, 1 to the 5th, which is going to give me the 5. X, 1 and 5 gives me 5. For the y, 2 and 5 gives me 10. And for the z, 3 and 5 gives me 15. If you wanted to finish simplifying completely, if it asks you to, you would have to solve 3 to the 5th power. So 3 times 3 times 3 times 3 times 3, which is going to give you an answer of 243 x to the 5th, y to the 10th, z to the 15th. So it depends on whether it asks you to write it in exponential form, where the number is written with the exponent, or in simplified form, where the number is actually written out. Go ahead and try this one on your own, writing it in simplified form. We end up with 256, h to the 12th, j to the 4th, k to the 8th. So we're going to do a couple that combine some of these properties that we have learned so far. So we got 3xy to the 4th, and then that is being multiplied with -2y to the 2nd to the 3rd. So this front part is all simplified. There's no extra power of a power. This second part we're going to need to simplify before we can do any multiplication. So I've got 3xy to the 4th stays put. Now we're going to work from inside out. So I'm going to say negative 2 to the 2nd power, which is going to give me negative 2 to the 2nd. And then we've got y to the 2nd. And all of that is still raised to the 3rd power. When you are trying to simplify, you want to get that to a number. So negative 2 times negative 2 is going to give you 4y. We still have a power of a power in that second expression. So we're going to leave this 3y, or 3xy to the 4th. Now we need to, again, bring that exponent in. And I'm going to say 4 to the 3rd, y to the 6th. We need to get that number 4 to the 3rd. 4 times 4 times 4 gives me 64 y to the 6th. Now that both parts are simplified individually, we're going to multiply them together. So we've got 3 times 64 giving us 192. And then we have the x times nothing. So we just have x. And then the last part, we've got y to the 4th times y to the 6th, giving me y to the 10th. So we have 192x y to the 10th when the expression is completely simplified. Go ahead and try this one on your own. Both of these have powers of powers to start, so we distribute the 2 here and the 2 here. We get our number answers for the possible number parts, and then we finish the multiplication and get 144, a to the 4th, b to the 10th, c to the 2nd. Next thing we're going to talk about is the division rules. So those first 3 rules are the rules for the multiplication or the power of power. Now we're going to talk about what happens if we throw some division in there. So the quotient of powers says that to divide 2 powers with the same base, we need to subtract their exponents. So I've got b to the 9th divided by b to the 5th, and that's going to give me b to the 4th. Why does this happen? Up top, we started with 9 b's being multiplied, and down the bottom, we had 5 b's being multiplied. When we cancel those out, b divided by b is going to go to 1, so all of those cancel out, and we're left with 4 b's, aka b to the 4th. So if we try this one, we look at our numbers, and we've got 8 over 2, which is 8 divided by 2, which gives me 4. Then we've got 7 k's divided by 5 k's is going to give me k to the 2nd. 10 m's, m to the 3rd is going to give us m to the 7th. 1 and 1 is going to give us nothing. So we've got 4 k to the 2nd, m to the 7th. Go ahead and try this one on your own. You end up with 8d to the 2nd, c to the 4th. Now, you noticed in that first example that we did, p to the 1st minus p to the 1st gave us p to the 0. What that says is following this next property, which is the 0 exponent property. So this says that any non-zero number raised to the 0 power is equal to 1. It is not equal to 0. It is equal to 1. Let me give you a quick explanation why. If we go 3 to the 3rd power, that's 3 times 3 times 3, which is going to equal 27. If I go 3 to the 2nd power, I've got 3 times 3. How did we get rid of this timesing 3? We divided by 3. So as we decrease the exponent, it's saying you're multiplying by less, aka you're dividing, which is going to give me an answer in this case of 9. 27 divided by 3 gives us 9. If we drop it down to 3 to the 1st power, that's just 3. To get rid of that multiplying by 3, we divided by 3. 9 divided by 3 is 3. So what happens when we drop the exponent again? We still have to continue the pattern, which was divide by 3. 3 divided by 3 is going to equal 1. It doesn't matter what number you have to start, this pattern is going to hold. as you go down by an exponent, you're dividing. When you get to anything to the first power, it equals itself. A number divided by itself is always going to equal 1. So anything to the 0 power is always going to equal 1. So if I have 2/7 to the 0 power, the answer is 1. If I have p divided by n to the 0 power, the answer is 1. Go ahead and try this one on your own. Looks super complicated, but again, anything to the 0 power is just equal to 1. So what happens as we continue? We have this next quotient of power, which says that similar to the multiplication one, you have to apply the power to everything. So if we've got 3/5 to the second power, that means we've got 3 to the second power over 5 to the second power, aka 9 over 25. On this bottom one, we've got the top goes to the second power, so 2 to the 5th power, and then p to the 10th power, over 3 to the 5th power, n to the 5th power. So again, this is another one of those distributive properties, and then we're going to want to finish simplifying our expression. We've got 2 to the 5th power, giving us 32p to the 10th, over 3 to the 5th power, giving us 243n to the 5th. So this quotient power rule is the exact same thing as power of power rule. It just means that it still applies if there is division. So if there's an exponent on the outside and stuff on the inside, you still have to distribute it to everything. Go ahead and try this one on your own. You end up with 4y to the 4th over 9y to the 6th. Last thing we're going to talk about is negative exponents and what those mean. So for any non-zero base, a negative exponent gives the reciprocal. So what this means is as we were going down and doing that 0 power, so I already established that 3 to the 1 is 3, 3 to the 0 gives us 1. What happens when we go into that negative power? The pattern still has to hold, so we're dividing by 3, so I end up with 1/3, or 1 over 3 to the 1st. If I would go down to 3 to the negative 2nd, that would give me 1 over 9 after I divide by 3, or 1 over 3 to the 2nd. So if you have this negative exponent, all it does is push that value to the denominator of a fraction. So if I've got 2 to the negative 4th power, that's going to give me 1 over 2 to the 4th power. The negative means you're dividing as you're going down, and division is in the denominator of a fraction. Now, what happens if the negative is in the denominator to start? Well, then that means we're going to have to flip it the other way, which is going to put us at 1 over y to the 4th, or just y to the 4th. So if the negative starts in the numerator, it gets pushed to the denominator. If it starts in the denominator, the value gets pushed to the numerator. Either way, it flips and makes itself positive. So, when we are simplifying expressions like this, my first suggestion to you is locate any negatives and move them. So we've got a to the negative 3rd. That's going to need to go up. B to the negative 1st needs to go up. C to the negative 4th needs to go up. C to the negative 5th needs to go down. So I've got 2, a to the 2nd, b to the 3rd. That didn't move. These 3 bottom pieces now come up top, a to the 3rd, b to the 1st, c to the 4th. The 10 did not move, and then our c to the negative 5 goes to the bottom. Now we can finish our simplifying. So I've got 2 over 10, which is going to give me 1/5. I've got a to the 2nd and a to the 3rd, giving me a to the 5th. I've got b to the 3rd and b to the 1st, giving me b to the 4th. And then I have c to the fourth and a c to the fifth on the bottom. Remember, if you're dividing, you're subtracting exponents, which gives me c to the negative first. 4 minus 5 is negative 1. We can't have a negative in our final answer, so that means this c to the first needs to go to the bottom, giving us 1, a to the fifth, b to the fourth, over 5, c to the first. If you don't want to include the ones, you do not have to. So your final answer could be a to the fifth, b to the fourth, over 5 times c. Go ahead and try this one on your own. So rearranging, we can do, bring that negative 5 to the bottom, that negative p to the bottom, and the the negative r to the top, giving me r to the third, n to the fifth, p to the third. If you have questions about this or anything else from the lesson, please let me know when you get to class.